Okay, in morning lecture, we have derived the derivation for the effectiveness of the counter fluid exchanger. So we get the equation for the counter fluid exchanger, that is 1 minus e raised to minus NTU into bracket 1 minus R divided by 1 minus R e raised to minus NTU into bracket 1 minus R. So this is the equation for the effectiveness for the counter fluid exchanger. Okay, counter fluid exchanger जर effectiveness काढायचं असेल तर आपण ते equation use करणार आहे. Okay, then now yes, sir, present the screen now. In that we have to consider the two cases for condenser and evaporator and when R is equal to 1. So for that two cases, what is the equations for the effectiveness for the parallel fluid exchanger and counter fluid exchanger? Now we have to write down that equations. Okay, so we have to consider the case number 1. Okay, so that two equations, effectiveness for parallel fluid exchanger and effectiveness for the counter fluid exchanger, we have written in the morning lecture. Now we have to consider the case number 1. So all of you write down case number 1. Case number 1. If suppose heat exchanger is nothing but condenser and evaporator is there. Condenser and evaporator is nothing but this is the type of the heat exchanger. Okay, condenser and evaporator are the type of heat exchanger. So for condenser and evaporator, one fluid is at constant temperature. जे काय आपण क्लासिफिकेशन ऑफ हीट एक्सचेंजर बघितलेलं आहे त्याच्यामध्ये आपण कंडेन्सर आणि इव्हॅपोरेटर बघितलेलं आहे. तर त्याच्यामध्ये काय असते, एक जे फ्लुइड असणार आहे त्याचं टेम्परेचर काय असणार आहे, कॉन्स्टंट असणार आहे. सो बिकॉज ऑफ दॅट व्हॉट विल हॅपन, द मॅक्झिमम हीट कॅपॅसिटी शुड बी इन्फिनिटी फॉर दॅट पर्टिक्युलर केस. ओके, एखाद्या हीट एक्सचेंजर मध्ये ज्या वेळेला one fluid is having constant temperature, at that time we get the infinity heat capacity rate. We get the maximum value of heat capacity rate as a infinity. Okay, so for the condenser and evaporator, one fluid is having constant temperature throughout the heat exchange process. जी काही heat exchange प्रोसेस असणार आहे त्याच्यामध्ये एक फ्लुइड जे असणार आहे त्याचं टेम्परेचर कॉन्स्टंट राहते, and because of that the maximum heat capacity for that particular fluid is infinity. Okay, so write down the case number 1. Case number 1 for condenser and evaporator. Case number 1 for condenser and evaporator. For condenser and evaporator, write down next line. For condenser and evaporator, one fluid is at, for condenser and evaporator, one fluid is at, for condenser and evaporator, one fluid is at, condenser and evaporator, one fluid is at constant temperature. One fluid is at constant temperature, and it is found that, and it is found that, and it is found that, and it is found that Cmax is equal to infinity, and it is found that heat capacity, maximum heat capacity जे असणार आहे ती किती असणार आहे, infinity असणार आहे. So it is found that Cmax is equal to infinity. Cmax is equal to infinity. Cmax is equal to infinity. Okay, so if numerator value, so R is equal to what? R is equal to C minimum upon C maximum. Heat capacity ratio म्हणजे R असणार आहे. And what is the equation for that? R, that is C minimum upon C maximum. If C maximum is infinity, then what is the value of R? R is equal to 0. So write down C max is equal to infinity. Therefore R is equal to, therefore R is equal to, therefore R is equal to C minimum upon C maximum. C minimum upon C maximum is equal to 0. R is equal to C minimum upon C maximum is equal to 0. R is equal to C minimum upon C maximum is equal to 0. Okay, so as we know that effectiveness for the parallel fluid exchanger, that equation we have written at the top, that is 1 minus e raised to minus NTU into bracket 1 plus R divided by 1 plus R. So now in that equation we have to put these values, that is R is equal to 0. If we are putting the value R is equal to 0, then therefore all of you write down, therefore effectiveness for parallel flow heat exchanger, effectiveness for parallel flow heat exchanger, effectiveness for parallel flow heat exchanger. Okay, so whatever the equation for the effectiveness of parallel flow heat exchanger, in that equation we have to put the value of R is equal to 0. जे काय आपण वरती इक्वेशन लिहिलेलं आहे, effectiveness of parallel flow heat exchanger, in that equation we have to put the value of R is equal to 0. So R is equal to 0 is the for the condenser and evaporator R is equal to 0. Now we have to put this value into that equation and we get the equation as a 1 minus e raised to minus NTU. Okay, so effectiveness for parallel flow heat exchanger is equal to 1 minus e raised to minus NTU. 1 minus e raised to minus NTU. 1 minus e raised to minus NTU. Okay, so this is the effectiveness for the parallel flow heat exchanger. Then again we have to put that value of R is equal to 0 in the equation of counter flow heat exchanger. So by putting that value R is equal to 0, then we get the equation as a 1 minus e raised to minus NTU. So same equation we get. Okay, so from that we said that effectiveness for the parallel flow and counter flow heat exchanger is same. And what is how to calculate that? That is 1 minus e raised to minus NTU. Okay, so this is the case for the condenser and evaporator. If condenser and evaporator is there, and at that time they said that we have to calculate the equation for the effectiveness for the parallel flow and counter flow heat exchanger. So at that time we have to find out the parallel effectiveness by using the equation 1 minus e raised to minus NTU. So this type of question is asked in the MCQ types of question. They have given the different equations and they told that which of the following is the correct equation for the effectiveness for the condenser and evaporator. At that time we have to remember this equation, that is epsilon is equal to 1 minus e raised to minus NTU. So by using this equation we have to calculate the effectiveness for the parallel and counter flow heat exchanger when there is a condenser and evaporator is there. Okay, so all of you write down effectiveness for parallel flow heat exchanger, then effectiveness for the counter flow heat exchanger, and these two equations are same. Therefore, effectiveness of parallel flow heat exchanger is equal to effectiveness for the counter flow heat exchanger, and it is calculated by using the equation 1 minus e raised to minus NTU. 1 minus e raised to minus NTU. So all of you write down these equations. Okay, then we have to consider the case number 2. Okay, so for the case number 1 कशासाठी असणार आहे तर कंडेन्सर आणि evaporator साठी असणार आहे. So for this case R is equal to 0. Therefore we get the effectiveness for the parallel flow and counter flow, and that equation is nothing but 1 minus e raised to minus NTU. Okay, so this is the case number 1. Now I have to consider the case number 2. Okay, so all of you consider the case number 2. तर केस नंबर 2 मध्ये काय असणार आहे, when R is equal to 1, when R is equal to 1 means capacity ratio is 1, and when this capacity ratio is 1 there is a typical regenerator is there, and for that typical regenerator R is equal to 1 is there. So all of you write down case number 2, when R is equal to 1, when R is equal to 1, typical regenerator is there, typical regenerator is there. Typical regenerator is there. Okay. So we have to put the value of R is equal to 1 in the equation of the effectiveness of the parallel flow heat exchanger. So by putting R is equal to 1, we get the equation as a, write down that equation. Effectiveness for parallel flow heat exchanger is equal to, effectiveness for parallel flow heat exchanger is equal to, effectiveness for parallel flow heat exchanger, effectiveness for parallel flow heat exchanger is equal to effectiveness for parallel flow heat exchanger is equal to, so put R is equal to 1 into that equation. So we get the equation as a 1 minus e raised to 1 minus e raised to minus 2 into NTU, 1 minus e raised to minus 2 into NTU, 1 minus e raised to minus 2 into NTU divided by 2, because R is equal to 1. So 1 plus 1, we get the 2 at the denominator. Okay. So effectiveness for parallel flow heat exchanger, what is that equation? 1 minus e raised to minus 2 NTU divided by 2, divided by 2. So this is the equation for the parallel flow heat exchanger. Okay. And second equation for the counter flow heat exchanger. So if we are putting the value R is equal to 1 into the equation of the counter flow heat exchanger, then we get the equation in the form of 0 by 0 form. And as we know that if 0 by 0 form is there, then we have to use the L'Hospital rule. And by using the L'Hospital rule, we get the equation for the effectiveness for the counter flow heat exchanger. And by using that, we get the equation as a NTU divided by 1 plus NTU. Okay. So first of all of you write down effectiveness for counter flow heat exchanger is equal to effectiveness for counter flow heat exchanger, effectiveness for counter flow heat exchanger is equal to, effectiveness for counter flow heat exchanger is equal to 1 minus, is equal to 1 minus 1 minus 1 minus e raised to 1 minus e raised to minus NTU, minus NTU into bracket 1 minus R, into bracket 1 minus R divided by 1 minus, divided by 1 minus R into e raised to, divided by 1 minus R into e raised to, R into e raised to minus NTU into bracket 1 minus R, e raised to minus NTU into bracket 1 minus R. So if we are putting the value R is equal to 1 into this equation, then we get the 0 by 0 form. Okay, we get the 0 by 0 form. So if 0 by 0 form is there, at that time we have to take the differentiation of the numerator and denominator, that is we have to use the L'Hospital rule, and by using the L'Hospital rule we get the effectiveness for the counter flow heat exchanger, that is the equation NTU divided by 1 plus NTU. Okay, so write down is equal to 0 by 0 form, therefore we have to take the limit R tends to 1, limit R tends to 1, limit R tends to 1, R tends to 1, 1 minus e raised to minus NTU into bracket 1 minus R, limit R tends to 1, 1 minus e raised to minus NTU into bracket 1 minus R, 1 minus e raised to minus NTU 1 minus R divided by 1 minus R, divided by 1 minus R e raised to minus NTU 1 minus R, divided by 1 minus R e raised to minus NTU 1 minus R. Okay, so we have to take the differential. What is mean by L'Hospital rule? For the L'Hospital rule, we have to take the derivative of numerator and denominator. Okay. So we have to differentiating numerator and denominator with respect to R. Next line we have to write down differentiating numerator and denominator, differentiating numerator and denominator with respect to R, differentiating numerator and denominator with respect to R, with respect to R, differentiating numerator and denominator with respect to R. Okay. So by taking the differentiation of numerator and denominator, we get the equation for the effectiveness for the counter fluid exchanger. And what is that equation? Take the differentiation of numerator and denominator. So at the numerator we get the NTU and at the denominator we get the 1 plus NTU. तुम्ही जर डेरिव्हेटिव्ह घ्या न्यूमरेटर आणि डिनॉमिनेटर with respect to R, तर तुम्हाला काय मिळेल? न्यूमरेटरला NTU मिळते आणि डिनॉमिनेटरला 1 plus NTU. ओके. तर गेट मध्ये पण अशा टाइपचे क्वेश्चन असतात. They have directly asking the equation for the effectiveness for the counter fluid exchanger. So there are 4 options. In that there is a one option that is effectiveness for counter fluid exchanger is equal to NTU divided by 1 plus NTU. So we have to remember this equation. This is very important for the MCQ type of questions. Okay. So whatever the equations we have written, effectiveness for parallel counter, for the case number 1, for the case number 2, or for the general equations, we have to remember all these equations. So if we have remembering this equation, it is easy to find out the equations for the case number 1, case number 2. Okay. So write down effectiveness for the counter fluid exchanger is equal to NTU plus NTU divided by 1 plus NTU. NTU divided by 1 plus NTU. Okay. So these are the equations for the case number 1 and case number 2. So in case number 1, for condenser and evaporator, we get the equation for the parallel fluid exchanger. That is effectiveness equation 1 minus e raised to NTU. And this equation is same for the effectiveness for the counter fluid exchanger. Okay. In case number 2, when we are considering R is equal to 1, so R is equal to 1, which is possible for the typical regenerator. And at that time, what is the effectiveness for the parallel fluid exchanger? That is 1 minus e raised to minus 2 NTU divided by 2. And for the counter fluid exchanger, what is the value of effectiveness? Is equal to NTU divided by 1 plus NTU. 1 plus NTU. Okay. So this is about the effectiveness and NTU method. तर याच्यामध्ये आपण दोन डेरिवेशन बघितलेले. फर्स्ट डेरिवेशन विच इज effectiveness for the parallel fluid exchanger. After that, we have completed the equation derivation for the effectiveness for the counter fluid exchanger, and then we have discussed the two cases, case 1 and case 2, and equations for that particular cases. Okay. So here we have completed the derivation part of the effectiveness and NTU method. Now we have to discuss some problems related to this method, that is effectiveness and NTU method. Okay. So all of you write down the first problem. All of you write down first problem. Write down first problem. All of you write down first problem. Write down a counter flow heat exchanger. A counter flow heat exchanger. A counter flow heat exchanger is employed. A counter flow heat exchanger is employed to cool. A counter flow heat exchanger is employed to cool to cool 0.55 kg per second, 0.55 kg per second, 0.55 kg per second. Once again, a counter flow heat exchanger to cool 0.55 kg per second, 0.55 kg per second, into bracket Cp is equal to 2.45. Cp is equal to 2.45 kilojoule per kg degree Celsius. Cp is equal to 2.45 kilojoule per kg degree Celsius. Bracket complete. Cp is equal to 2.45 kilojoule per kg degree Celsius. Bracket complete. Of oil, of oil, of oil, of oil from of oil from 115 degree Celsius to of oil from 115 degree Celsius, 115 degree Celsius to 115 degree Celsius to 40 degree Celsius, to 40 degree Celsius, 40 degree Celsius by the use of water, 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 full stop. The inlet and outlet temperature of the inlet and outlet temperature of the inlet and outlet temperature of cooling water, the inlet and outlet temperature of the inlet and outlet temperature of cooling water are cooling water are 15 degrees Celsius and 75 degrees Celsius. The inlet and outlet temperature of cooling water are 15 degrees Celsius and 75 degrees Celsius respectively, 75 degrees Celsius respectively, respectively, full stop. The overall heat transfer coefficient, the overall heat transfer coefficient, the overall heat transfer coefficient is expected to be, the overall heat transfer coefficient is expected to be is expected to be 1450 1450 watt per meter square degree Celsius. The overall heat transfer coefficient is expected to be is expected to be 1450 1450 1450 expected to be 1450 watt per meter square degree Celsius, watt per meter square degree Celsius, full stop. Using NTU method, using NTU method, using NTU method, using NTU method, calculate the following, calculate the following, calculate the following, calculate the following. That on first, calculate the following. First, first, the mass flow rate of water, the mass flow rate of water, the mass flow rate of water, mass flow rate of water. Second, the effectiveness of the heat exchanger, the effectiveness of the heat exchanger, effectiveness of the heat exchanger, and the surface area required, and the surface area required, surface area required, surface area required. So all of you read that problem carefully, and you have to write down given things by your own. Okay, तर कुठला हीट एक्सचेंजर दिलेला आहे, त्यांनी काय काय दिलेलं आहे. सो ऑल ऑफ यू राईट डाउन दी फर्स्ट. We have to read the problem carefully. Okay, so I will help you to write down the given things. Okay, okay. A counter flow heat exchanger means we have to understood in this case the direction of hot fluid and cold fluid is opposite. Okay, so they have given the counter flow heat exchanger is there, is employed to cool 0.55 kg per second of oil from 115 to 40 degrees Celsius. Means oil is nothing but hot fluid, and hot fluid temperature is reduces from the 115 to 40 degrees Celsius, and having mass flow rate is given 0.55. Means m dot h is given. Oil is nothing but hot fluid. They given the temperature is reduces. So hot fluid having temperature is reduces. So therefore oil is nothing but hot fluid. Okay. So mass flow rate is given for that particular hot fluid. So therefore m dot h is equal to 0.55 kg per second, and Cp of the hot fluid is also given, that is Cph is equal to 2.45 kilojoule per kg degree Celsius. Okay, mass flow rate is given for the hot fluid, then specific heat of the hot fluid is given, that is 2.45. Then inlet temperature of the hot fluid is given, that is Th1 is equal to 115 degrees Celsius. Okay, temperature of the hot fluid at inlet, that is 115 degrees Celsius, and the temperature of the hot fluid at the outlet, that is Th2 is given, that is 40 degrees Celsius. Okay, या सर फक्त गिवन थिंग्स दिसतील एवढी वरती घ्या. Okay, so okay, mass flow rate of the hot fluid, then specific heat of the hot fluid, then Th1 and Th2 is given. Okay, then the inlet and outlet temperature of the cooling waters are also given. Means Tc1 is given and Tc2 is given. Inlet temperature is nothing but Tc1, and outlet temperature is nothing but Tc2. Okay, so Tc1 is equal to 15 degrees Celsius and Tc2 is nothing but 75 degrees Celsius. Okay, then they given the overall heat transfer is coefficient is expected to 1450 watt per meter square degree Celsius. Okay, so capital U is given, capital U is equal to 1450 watt per meter square degree Celsius. Okay, overall heat transfer coefficient is denoted by capital U. So capital U is given, capital U is equal to 1450 watt per meter square degree Celsius. Okay, so using NTU method calculate the following. तर त्यांनी काय सांगितलेलं आहे, NTU मेथडचा यूज करा and we have to calculate the following things. Okay, so what are the different things we have to find out? First one, the mass flow rate of the water. Okay, so here mass flow rate of the hot fluid is given, but they have said that we have to calculate the mass flow rate of the cold fluid, means we have to calculate the value of m dot c. So all of you write down m dot c is equal to question mark. First we have to calculate the value of the mass flow rate of the water, that is m dot c is equal to question mark. Then second, the effectiveness of the heat exchanger, means we have to calculate the effectiveness. This is the counter flow heat exchanger, so we have to calculate the epsilon is equal to question mark. So for the counter flow heat exchanger we have to calculate the effectiveness, so epsilon is equal to question mark. Then surface area required, that is A is equal to question mark. A is equal to question mark. Okay, so I have drawn that graphical representation, that is counter fluid exchanger is there. So hot fluid is nothing but oil, then cold fluid is nothing but water, and the direction of oil and water is opposite. So oil having inlet temperature is TH1, outlet temperature is TH2, and for the water inlet temperature is TC1 and outlet temperature is TC2. Okay. So first we have to calculate the mass flow rate of the water. Can anyone tell me how to calculate the mass flow rate of the water? Already we have calculated the mass flow rate of the water. That type of problem we have solved in the LMTD method also. So which equation we have used there? So that same equation we have to use here, and we have to find out the value of the mass flow rate of the water. Can anyone tell me what is the equation for that? Anyone? Unmute yourself and tell me the which equation we have to use to calculate the value of mass flow rate of the water. Anyone? How to calculate the mass flow rate of the water? Because whatever the information related to the hot fluid, that information is given to us. Okay, and related to the cold fluid, inlet temperature and outlet temperature is also given. Only unknown thing is that the mass flow rate of the cold fluid. So which equation we have to use so that we get the value of m dot c? Can anyone tell me? Anyone unmute yourself and tell me which equation we have to use to calculate the value of m dot c? Anyone? कोण सांगतंय का कोणालाच येत नाही?
Heat lost by hot fluid is equal to heat gained by cold fluid.
Okay, so what is the equation for the heat loss by the hot fluid?
M dot C into
Yes, sir.
TH1 minus TH2.
Once again, we have told that what is the equation for the heat loss by the hot fluid?
MCP delta T.
MCP delta T. So, okay. So we have to use that equation, and by using that equation, we have to calculate the value of m dot c. ओके, समजले का बघा सगळ्यांना? जे काही हॉट फ्लुइड आहे ते काय करणार आहे, आपली एनर्जी कोल्ड फ्लुइडला देणार आहे. म्हणजे हीट लॉस्ट बाय द हॉट फ्लुइड इज इक्वल टू हीट गेन बाय द कोल्ड फ्लुइड. And as we know that what is the equation for the heat lost or heat gain, that is mcp delta t. Okay, so heat lost by hot fluid, what is the equation for that? M dot h cph into th1 minus th2 is equal to heat gain by the cold fluid. What is the equation for that? M dot c into cpc into tc2 minus tc1. So in this equation only unknown quantity is that m dot c. Okay, so all of you put that values into this equation and find out the value of m dot c. Okay, yes sir, take at the upper side only that part we have to take at the upper side, m dot c calculation. Okay, so we have to use this equation: heat lost by hot fluid is equal to heat gained by the cold fluid. Heat gained by the cold fluid. So what is the equation for the heat lost by the hot fluid? That is m dot h into cph into bracket th1 minus th2 is equal to m dot c into cpc into bracket tc2 minus tc1. Okay, so m dot h is given, cph is given, th1 is given, th2 is given, m dot c is unknown to us. Then cpc म्हणजे specific heat of water, that value is standard value, that is 4.18. tc2 is given, tc1 is given. So only unknown quantity is m dot c. Okay, so all of you put the values into this equation and find out the value of mass flow rate of the water. Mass flow rate of the water. Okay, all of you put these values into this equation and find out the value of m dot c. Okay, so after the calculation we have to put that answer in the chat box. Whether that answer is correct or all of you get that same answer. Okay, do the calculation by yourself and find out the mass flow rate of the water. Mass flow rate of the water, that is m dot c. Okay, yes sir, I have calculated the answer 0.402. Okay, what about others? Simple calculation you have to do by yourself and put that answer in the chat box. Okay, then we have to find out the effectiveness of the heat exchanger. So for the calculation of the effectiveness, there is a need of heat capacity for the hot fluid and heat capacity for the cold fluid. So first of all, we have to calculate the value of Cc and then we have to calculate the value of Ch. So how to calculate the value of Cc? That is, heat capacity is nothing but mass flow rate into specific heat. Mass flow rate into specific heat. Okay. So for the calculation of Cc, write down that equation m dot c into Cpc. So m dot c is nothing but 0.4 and Cp of water is nothing but 4.18. Okay, so first of all of you calculate the value of Cc and then we have to calculate the value of Ch. Okay, so all of you get the value of Cc and Ch. So as we know that mass flow rate and product of mass flow rate and specific heat is nothing but heat capacity. So we get the value of Cc and Ch. So from these two value, we have to understood which value is minimum and which value is maximum. So Cc is What is the value of CC? That is 1.672. And what is the value of CH? That is 1.347. So from this we have to understand that C max is nothing but CC and C minimum is nothing but CH. Okay. So CC is greater than CH. CC is greater than CH means that C max is nothing but CC and C minimum is nothing but CH. Okay. And we know that what is the equation for the effectiveness? Effectiveness is equal to CH into bracket TH1 minus TH2 divided by C minimum into bracket TH1 minus TC1. Okay. C minimum is nothing but CH. So all of you put that values into this equation and we get the value of effectiveness. समजले का बघा ह्या केस मध्ये सीसी ची व्हॅल्यू जास्त आहे म्हणजे सी मॅक्स इज इक्वल टू काय झालं सीसी झालं and C minimum is equal to CH झालं. And what is our standard equation to calculate the value of effectiveness? That is effectiveness is equal to CH into bracket TH1 minus TH2 divided by C minimum into bracket TH1 minus TC1. C minimum म्हणजे CH आहे. So therefore instead of C minimum we have to put the CH. So what is the equation? CH into bracket TH1 minus TH2 divided by CH into bracket TH1 minus TC1. So CH will be cancelled. So what is the equation? Effectiveness is equal to TH1 minus TH2 divided by TH1 minus TC1. So TH1 is given as a 115, TH2 is given as a 40 and TC1 is given as a 15. So all of you put that values into this equation and we get the value of effectiveness. Okay. So all of you write down these things and we get the value of effectiveness. We get the value of effectiveness that is 0.75. 0.75. समजले का बघा सगळ्यांना. तर ज्यावेळेला आपल्याला इफेक्टिव्हनेस फाइंड आउट करायचं असते तर त्यावेळेला तुम्हाला हीट कॅपॅसिटीची कुठली व्हॅल्यू मॅक्झिमम कुठली व्हॅल्यू मिनिमम हे लक्षात यायला पाहिजे. सो फर्स्ट ऑफ ऑल यू हॅव टू कॅल्क्युलेट द व्हॅल्यू ऑफ सीसी, देन वी हॅव टू कॅल्क्युलेट द व्हॅल्यू ऑफ सीएच. सो फ्रॉम दॅट टू व्हॅल्यूज वी हॅव टू अंडरस्टूड which value is maximum, which value minimum, and according to that we have to use the equation and find out the effectiveness. Okay, so next, third, we have to calculate the surface area. So as we know that in NTU method, what is the equation for the NTU? NTU is nothing but NTU is equal to U into A divided by C minimum. U into A divided by C minimum. So in that equation, by using that equation, we have to calculate the value of A. So U value is given to us, C minimum is known to us. Okay. Then we have to find out the value of NTU first, so that we have calculate the value of area. So how to calculate the value of NTU? So for the counterflow exchanger, we have to use the equation of the effectiveness, and by using that equation, we have to calculate the value of NTU, and by using the NTU equation, we have to find out the value of area. Okay. So for the calculation of the effectiveness for the counterflow exchanger, there is a need to calculate the value of R. So R is nothing but C minimum upon C maximum. Okay, C minimum is nothing but CH and C maximum is nothing but CC. So from that we get the value of R. Okay, so all of you write down R is equal to C minimum divided by C maximum. R is equal to C minimum divided by C maximum. So calculate the value of R. Okay, continue. Two lectures are there. Don't put your roll numbers in the chat box. After half an hour, we have to put your roll numbers in the chat box. Okay, don't put again and again roll numbers in the chat box. Okay, so first of all, you have to calculate the value of R. R is equal to C minimum upon C maximum. So C minimum is nothing but CH, C maximum is nothing but CC. So we already have calculated the value of CH and CC. So CH is 1.347 and CC is nothing but 1.672. So from this calculation, we get the value of R. So R is equal to 0.806. 0.806. Okay, 0.806. Then what is the equation for the effectiveness for the counterflow exchanger? So in earlier calculation, for the calculation of effectiveness, we have used the general equation. But for the counterflow exchanger, what is the equation for the effectiveness? Effectiveness is equal to 1 minus e raised to minus NTU into bracket 1 minus R divided by 1 minus R into e raised to minus NTU into bracket 1 minus R. Okay. So by using this equation, we have to calculate the value of NTU. Okay, so epsilon is known to us, then R is known to us, only unknown quantity is NTU. So by doing this simplification, we have to find out the value of NTU. Okay, so all of you do the calculation by yourself. याचं कॅल्क्युलेशन सगळ्यांनी स्वतः करा, त्याशिवाय तुम्हाला ह्याच्यामध्ये काय चुका होतात ते समजणार नाहीत, लक्षात ठेवा. कारण अशी जी इक्वेशन असतात ती कॅल्क्युलेशन करताना ह्याच्यामध्ये बऱ्याच चुका होत असतात. ओके, सो ऑल ऑफ यू टेक 2-3 minutes for this calculation and do the calculation by yourself and find out the correct value of NTU. Already I have calculated the answer for the NTU. That answer is 2.367, 2.365. But we have to do the calculation by yourself. Okay, so that we have to easily understood how to calculate this type of equations. Okay, so take the 2-3 minutes for this calculation and find out the answer of the NTU. Okay. Okay, all of you get the answer for the NTU. NTU is equal to 2.365. All of you put your answer in the chat box. That answer is correct or wrong? Okay, Dhanush have put their answer 2.364. Okay, so NTU is equal to 2.365. Okay, so this is the correct answer. So those who are remaining, do the calculation by yourself. We have to understood such type of equations how to solve by using the calculator. Okay, so we get the answer for the NTU. NTU is equal to 2.365. Okay, so our aim is to calculate the surface area. So as we know that in the equation of NTU there is a area. So NTU is equal to U into A divided by C minimum. So by using that equation, we have to write down the equation for the area. So area is equal to NTU into C minimum divided by U. Okay, so NTU is nothing but 2.365 into C minimum is nothing but CH, and what is the value of CH? That is 1.347. That answer is in kilowatt, so we have to convert it into watt. So 1.347 into 10 raised to 3 and divided by overall heat transfer coefficient, that is U is given in the given things. So 1450. So from that we get the surface area required to transfer that much amount of heat. Okay, so write down this. NTU is equal to U into A NTU is equal to U into A divided by C minimum. So from this equation, what is the equation for the area? Area is equal to NTU into C minimum divided by U. So NTU we have calculated the value, that is 2.365 into C minimum. So C minimum is nothing but CH. What is the value of CH? That is 1.347 kilowatt per Kelvin आहे ते वॅट मध्ये कन्वर्ट केलेलं आहे. सो इन 1.347 into 10 raised to 3 divided by C minimum, sorry, divided by U. So that value is given to us, that is 1450 watt per meter square degree Celsius. So by putting this value, we get the value for the area. We get the value for the area. So area is equal to 2.197 meter square. 2.197 meter square. Okay, all of you get the answer for the area, surface area 2.197 meter square. समजलं का सगळ्यांना? सी मॅक्स म्हणजे काय, सी मिनिमम म्हणजे काय, इफेक्टिव्हनेस साठी इक्वेशन कुठलं वापरायचं, एनटीयू मेथडसाठी कुठलं इक्वेशन यूज करायचं, त्याच्यावरनं एरिया कसा कॅल्क्युलेट करायचा. ओके, so this is the way, by using that we have to calculate the surface area of that particular heat exchanger. Surface area for that particular heat exchanger. Okay, so this is the first problem related to the effectiveness and NTU method. So all of you write down the second problem. Write down the second problem. Write down the second problem. Okay, so all of you write down the second problem. 16.5 kg per second of the product. 16.5 kg per second of the product. 16.5 kg per second of the product at 650 degrees Celsius. Product at 650 degrees Celsius. 650 degrees Celsius. In bracket Cp is equal to, in bracket Cp is equal to 3.55 kilojoule per kg degree Celsius, 3.55 kilojoule per kg degree Celsius, 3.55 kilojoule per kg degree Celsius in a chemical plant, in a chemical plant, in a chemical plant are to be used, in a chemical plant are to be used, chemical plant are to be used to heat, are to be used to heat 20.5 kg per second, are to be used to heat 20.5 kg per second, 20.5 kg per second of the incoming fluid, of the incoming fluid, of the incoming fluid from 100 degrees Celsius, incoming fluid from 100 degrees Celsius, 100 degrees Celsius, in bracket Cp is equal to 100 degrees Celsius, in bracket Cp is equal to 4.2 kilojoule per kg degree Celsius, Cp is equal to 4.2 kilojoule per kg degree Celsius, bracket complete, full stop. Cp is equal to 4.2 kilojoule per kg degree Celsius, bracket complete, full stop. If the overall heat transfer coefficient is, if the overall heat transfer coefficient is, if the overall heat transfer coefficient is, if the overall heat transfer coefficient is 0.95, if the overall heat transfer coefficient is, if the overall heat transfer coefficient is 0.95 kilowatt per meter square degree Celsius, if the overall heat transfer coefficient is 0.95 kilowatt per meter square degree Celsius, 0.95 kilowatt per meter square degree Celsius, and the installed heat transfer surface, and the installed heat transfer surface, and the installed heat transfer surface is, heat transfer surface is 44 meter square, installed heat transfer surface is 44 meter square, installed heat transfer surface is 44 meter square, 44 meter square. Calculate the fluid outlet temperature, calculate the fluid outlet temperature, calculate the fluid outlet temperature for the counter flow, calculate the fluid outlet temperature for the counter flow and parallel flow arrangements, calculate the fluid outlet temperature for the counter flow and parallel flow arrangements, counter flow and parallel flow arrangements. Okay, so all of you read that problem carefully and understood the given things. Okay, 16.5 kg per second of the product at 650 degrees Celsius in a chemical plant are to be used to heat. ओके, म्हणजे हा 16.5 जो आहे तो मास फ्लो रेट ऑफ कशाचा असणार आहे, हॉट फ्लुइडचा असणार आहे. ओके, सो m dot h is given, so all of you write down the given things. M dot h is equal to 16.5 kg per second. Okay, and the inlet temperature of the hot fluid is given, means th1 is given, th1 is equal to 650 degrees Celsius, th1 is equal to 650 degrees Celsius, and Cp of that hot fluid is also given, that is Cph is equal to 3.55 kilojoule per kg degree Celsius. Okay, in a chemical plant are to be used to heat 20.5 kg per second of the incoming fluid. Okay, so means mass flow rate of the cold fluid is given, that is m dot c is equal to 20.5 kg per second, m dot c is equal to 20.5 kg per second of the incoming fluid from 100 degrees Celsius. Okay, means inlet temperature of the cold fluid is also given, that is Tc1 is equal to 100 degrees Celsius, Tc1 is equal to 100 degrees Celsius. And Cp of the cold fluid is also given, that is Cp of cold fluid, that is Cpc is equal to 4.2 kilojoule per kg degree Celsius. Cp is equal to Cp of cold fluid, that is Cpc is equal to 4.2 kilojoule per kg degree Celsius. Okay. And if the overall heat transfer coefficient is 0.95 kilowatt per meter square degree Celsius. Okay. Overall heat transfer coefficient is denoted by capital U. So capital U is equal to 0.95 kilowatt per meter square degree Celsius. 0.95 kilowatt per meter square degree Celsius. And the installed heat transfer surface is 44 meter square, means area is given, area is equal to 44 meter square. 44 meter square. Then calculate the fluid outlet temperature for the counter flow and parallel flow arrangement. तर आपल्याला पॅरलल फ्लो अरेंजमेंटसाठी आणि काउंटर फ्लो अरेंजमेंटसाठी काय फाइंड आउट करायचे आहेत, आउटलेटची टेम्परेचर फाइंड आउट करायचे आहेत. म्हणजे त्यांनी TH1 आणि TC1 दिलेला आहे. And they have said that we have to calculate the outlet temperature, means we have to calculate the outlet temperature of the hot fluid and outlet temperature of the cold fluid for the parallel flow arrangement and for the counter flow arrangement. समजलं का बघा. TH2 आणि TC2 फाइंड आउट करायचं आहे. TH2 आणि TC2 पॅरलल फ्लो साठी फाइंड आउट करायचं आहे आणि TH2 आणि TC2 काउंटर फ्लो साठी फाइंड आउट करायचं आहे. ओके, सो राइट डाउन दी TH2 is equal to question mark and TC2 is equal to question mark. Okay, TH2 is equal to question mark and TC2 is equal to question mark. Okay, so we have to find out the effectiveness. Then we have to use the equation for the effectiveness. So for the calculation of the effectiveness, there is a need of CH and CC. So first of all, we have to calculate the CH and CC. So from that, we have to understand what is the value of C minimum, what is the value of C maximum. Then we have to find out the R. From that, we get the value of NTU. Then we have to calculate the value of effectiveness. Then we have to use the equation for the effectiveness. And from that equation, we have to calculate the value of TH2 and TC2. This is very simple problem first, but you have to understood which quantities are unknown to us. So by using that, we have to use the different equations, and by using that equations, we have to calculate the values of TH2 and TC2. Okay, so for the calculation of this, first of all, you have to consider the counter flow arrangement. So all of you write down first counter flow arrangement. म्हणजे counter flow arrangement साठी आपल्याला TH2 आणि TC2 find out करायचा. Okay, so first of all, we have to consider the counter flow arrangement. So write down counter flow arrangement. Counter flow arrangement. So first of all, we have to calculate the heat capacity for the hot fluid and cold fluid. Means we have to calculate the value of CH and CC. Okay, how to calculate the value of CH? CH is equal to m dot h into CPH. Okay, so m dot h is given 16.5, CP is given 3.55. So from that we get the value of CH, that is 58.6 kilowatt per Kelvin. Okay, and similarly we have to calculate the value of CC. CC is equal to m dot C into CPC. M dot C is nothing but 20.5 and CPC is nothing but 4.2. So from this calculation we get the value of CC, that is 86.1 kilowatt per Kelvin. So from this value of CH and CC, CH is 58.6, CC is 86.1. So from these two value we have to understood that the value of CC is greater as compared to the CH. So from that we said that C minimum is nothing but CH and C maximum is nothing but CC. Okay. So from that we have to calculate the value of R. R is nothing but C minimum upon C maximum. C minimum काय आहे तर CH आहे, C maximum काय आहे तर CC आहे. So 58.6 divided by 86.1. So from that we get the value of R, that is 0.68. And as we know that what is the equation for the NTU? NTU is equal to U into A divided by C minimum. Okay. So U is given to us, A is given to us, C minimum we have calculated that value, that is 58.6. So from this calculation we get the value of NTU, that is 0.71. Okay. And for the counter flow arrangement, we know that equation for the counter flow arrangement for the effectiveness, that is effectiveness is equal to 1 minus e raised to minus n2 into bracket 1 minus r divided by 1 minus r into e raised to minus n2 into 1 minus r. So all of you already we have calculated the value of n2, r, we have to put this value into this equation. From this calculation simplification we get the value of effectiveness. And what is the value of effectiveness? That is 0.443. Okay, and we have two equations for the effectiveness. That is effectiveness is equal to ch into bracket th1 minus th2 divided by c minimum into th1 minus tc1. So c minimum is nothing but ch. So from this equation we get the equation for the effectiveness as a th1 minus th2 divided by th1 minus tc1. So by putting the value into this equation, only unknown quantity is th2. So from this equation we get the value of th2. And similarly, what is the another equation for the effectiveness for the cold fluid? We are using as a effectiveness is equal to cc into bracket tc2 minus tc1 divided by c minimum into bracket th1 minus tc1. So in that equation only unknown quantity is tc2. So by putting the values into this equation we get the value of tc2. Okay, so all of you do the calculation by yourself. First of all, we have to calculate the value of CH, then CC, then what is mean by relation, that is CH is less than CC. So C minimum is nothing but CH, C max is nothing but CC. So from that we get the value of R. R is nothing but C minimum upon C maximum. So from that we get the value of R is equal to 0.68. Okay. Then what is the equation for the NTU? NTU is nothing but U into A divided by C minimum. So U is 0.95, A is nothing but 44, and C minimum is nothing but 58.6. So from that we get the value of NTU, that is 0.71. And what is the equation for the effectiveness for the counterflow exchanger? That is, what is that equation? 1 minus e raised to minus NTU 1 minus R divided by 1 minus R e raised to minus NTU 1 minus R. So by putting the value of NTU and R into this equation, we get the value of effectiveness as a 0.443. Okay, all of you complete up to this 0.443 value of effectiveness. Okay, I will give 2 minutes to solve up to the effectiveness value, that is 0.443. Do the calculation by yourself so that it is very easy to find out the different calculations. Okay, all of you do the calculation up to the effectiveness is equal to 0.443. Okay, so all of you understood process how to calculate the outlet temperature. So first of all we have to calculate CH, CC, then R, then NTU, then effectiveness, and from that effectiveness equation we have to calculate the value of TH2 and TC2. Okay, so we get the value of effectiveness is equal to 0.443. 0.443. Then next, so as we know that what is the equation for the effectiveness? Effectiveness is equal to CH into bracket TH1 minus TH2 divided by C minimum into TH1 minus TC1. C minimum म्हणजे CH आहे, म्हणजे CH CH cancel होईल. What is the remaining equation? TH1 minus TH2 divided by TH1 minus TC1. ह्याच्यामध्ये व्हॅल्यूज पुट करा, we get the value of TH2. And similarly we have to use the equation for the effectiveness when the cold fluid is there. So what is that equation? Effectiveness is equal to CC into bracket TC2 minus TC1 divided by C minimum into bracket TH1 minus TC1. So all of you put the values into this equation, and in this equation only unknown quantity is TC2. So from this calculation we get the value of TC2 as a 265.8 degrees Celsius. Okay, all of you do the calculation for TH2 and TC2. This is the outlet temperature for the counter flow arrangement. म्हणजे ज्यावेळेला हीट एक्सचेंजर तुमचा काउंटर फ्लो असणार आहे त्यावेळेला तुम्हाला आउटलेटची टेम्परेचर म्हणजे हॉट फ्लुइडचं आउटलेटचं टेम्परेचर 406 मिळणार आहे आणि कोल्ड फ्लुइडचं आउटलेटचं टेम्परेचर 265 भेटणार आहे. Okay, so this is the way by using that we have to calculate the outlet temperature for the counter flow arrangement. counter flow arrangement. And similarly we have to do the calculation for the parallel flow arrangement. म्हणजे parallel flow साठी तुम्ही इफेक्टिव्हनेस फाइंड आउट करा आणि हे जी आपण इक्वेशन वरती यूज केले तीच इक्वेशन तुम्ही यूज करा. त्याच्यावरून तुम्हाला काय मिळेल, TC2 आणि TH2 मिळेल फॉर द parallel flow arrangement. Okay, so first of all we have to calculate the value of TH2 and TC2 for the counter flow arrangement. Okay, all of you get the value of TH2, that is 406.35 degrees Celsius. Now we have another equation for the effectiveness. In that equation we are using the terms related to the cold fluid, that is effectiveness is equal to Cc into bracket Tc2 minus Tc1 divided by C minimum into bracket Th1 minus Tc1. Okay, so in this equation we have to put the all values which is known to us and find out the value of Tc2. Okay, yes sir, take it upside. Okay, so put the value into this equation and we get the value for the Tc2. Okay, so we get the value of Tc2 as a 265.8 degrees Celsius. So Th2 and Tc2, this is the outlet temperature for the hot fluid and cold fluid for the counter flow arrangement. Now we have to find out the values of TH2 and TC2 for the parallel flow arrangement. तर डिफरन्स काय येणार आहे, इफेक्टिव्हनेस जो फाइंड आउट केलेला आहे आपण काउंटर फ्लो साठी वेगळे इक्वेशन असणार आहे, पॅरलल फ्लो मध्ये वेगळे इक्वेशन असणार आहे. सो नाउ वी हॅव टू कॅल्क्युलेट द व्हॅल्यू ऑफ इफेक्टिव्हनेस फॉर द पॅरलल फ्लो अरेंजमेंट, and from that value of effectiveness we have to calculate the value of TH2 and TC2. Okay, so all of you write down the second point for the parallel flow arrangement. For the parallel flow arrangement, for the parallel flow arrangement, all of you completed the counter flow arrangement TH2 and TC2 value. I will proceed. Shall I proceed? Anyone? All of you completed that calculation for the TH2 and TC2. Okay, all of you completed TH2 and TC2 calculation. Then we have to write down the second arrangement, that is parallel flow arrangement. So yes sir, take at the upside. For parallel flow arrangement we have to calculate the TH2 and TC2. So for the parallel flow arrangement there is a another equation for the effectiveness. So what is the equation for the effectiveness for the parallel flow arrangement? Effectiveness is equal to 1 minus e raised to minus NTU into bracket 1 plus r divided by 1 plus r. So already we have calculated the value of NTU and r. So we have to put the value of NTU and r into this equation and find out the value of effectiveness. So by the doing the calculation we get the value for the effectiveness as equal to 0.415. 0.415. Okay, and then what is the equation for the effectiveness? For the, if cold fluid is considering, then Cc into bracket Tc2 minus Tc1 divided by C minimum into bracket Th1 minus Tc1. Okay, so same equations that we have used in the counter flow arrangement, that same equations we have to use in this case and find out the value of Th2 and Tc2. Okay, so by the doing the calculation we get the value for the Tc2, and then we have to use that equation. Effectiveness is equal to Ch into bracket Th1 minus Th2 divided by C minimum into Th1 minus Tc1. So by simplification we get the value of Th2. Okay, so by the for the parallel flow arrangement we get the value of effectiveness as a 0.415. आपण म्हणतोय बघा इफेक्टिव्हनेस जो आहे तो काउंटर फ्लो अरेंजमेंट साठी जास्त असतोय किंवा जी LMTD असते, तर इथं पण तुम्ही जर कॅल्क्युलेशन केलं तर तुम्हाला जाणवलं असेल, तर इफेक्टिव्हनेस किती आलेला आहे पॅरलल फ्लोचा 0.415. Okay, then by using the effectiveness equation we have to calculate the value of Tc2 and Th2. Okay, so effectiveness is equal to Cc into bracket Tc2 minus Tc1 divided by C minimum into bracket Th1 minus Tc1. Okay, effectiveness we have calculated as a 0.415. So by using this equation we have to calculate the value of Tc2. Okay, yes sir, take it upside. Okay, so by using these two equations we have to calculate the value of Tc2 and Th2. Same equation as in the upper, in the earlier arrangement, that is counter flow arrangement, we have calculated the value of Th2 and Tc2. That same equations we have to use to find out the value of Th2 and Tc2. So here we have to calculate the first, that is Tc2 value, and then we have calculated the value of Th2. We have to use the same equation, only difference is in the effectiveness value. In earlier case there is a different value of effectiveness, and in this case there is a different value of effectiveness. Okay, so because of that we get the different values of Th2 and Tc2. Okay, so TC2 we get the value as a 255.4 degrees Celsius, and do the calculation for the TH2 and put that answer in the chat box. What is the answer for the TH2? Okay, so all of you do the calculation for the TH2 and write that, put that answer in the chat box. So I have taken the attendance of you. So put your roll numbers in the chat box. Here we have to stop. Remaining part we have to take in the tomorrow's lecture. Okay. So now in this topic only one part, one problem we have to take, and one point is remaining, that is heat pipe. So in the next lecture we have to complete this heat exchanger topic, that is unit number 6. Okay. So total 4 topics we have completed, that is unit number 1. Section 1 is already completed, 1, 2, 3. And from the section 2, now we have completed unit number 6. Only one problem we have to take in the next lecture, so that our 6th topic will be completed. So only 2 topics are remaining, convection and condensation and boiling. Okay, condensation and boiling very simple and small topic is there, and convection is, there is a bigger topic is there. Okay, so we have to stop here. Already I have taken your attendance. Yes sir, stop the recording and leave the meeting. One problem we have to take in the next lecture. So thank you very much.